Analysis and design, as I just say, analysis, there can be a few types of analysis in Tekla Structural Designer. The basic one that we do is non-sway analysis. It means we don't need to consider the sway of the buildings, okay? That's called the first order analysis. Under the first order analysis, we can choose actually what kind of analysis we want. So once you run your analysis, what we do next is we see whether the beam results are as per our expectations or not. Whether if the bending moment diagram and the shear force diagram that are shown is correct or not. Whether what we see is the whether your framing is correct or not. To see that, we go into this review tab. Okay, so you see here is a diagram of a bending moment, shear force, and deflection. This is one example. Maybe see we want to select the first beam. We want to see the first beam's bending moment diagram. We select that beam only, and we can see the results of that beam under this review tab. Okay, then the analysis is done. You are sure that your modeling is okay, you're sure your loading is okay. The next step is to design the member. Now, here is one option in the software that can give you the auto design of members. It means it will automatically design and resize your member to optimize. Like if the member we give, suppose I give the column a size of ISMB 500, and the ratio for that column is 0.5. So it's not very economical. So what it will do is it have an option to auto design and change the member size to say something more suitable with a ratio of 0.75 to 0.8, which is an optimum size, which is economical size. Okay, so it have that option of auto design of member, but we don't always have to use the auto design of members. Sometimes we want to maintain the size we provided, right? So in that case, what we do is we have to tick off the auto design member under this tab, under this uh, property window. When we are assigning the property, here we will have an option to auto design. If you can see here already, I have unticked. That's the option where you can untick and not choose to auto design as per the software. We can give the member size and want that member size. If it doesn't work, we change it ourselves as per our requirement. So that's auto design. So once we design the member, the next step is to look into the design status, like which members are failing, which members are showing warnings. How to do that? We have an option called review member site review tab. Under the review tab, you will see your design like something like this. You can see it giving a color code. The green is choosing as 0.6. Then the red, if there's a red in here, it means the member is failing because it's 1. So we can we can interact with our model using this 3D visualization. It's very helpful in looking at what members are passing or what is the status of a design at one shot. You don't have to go and search for which members are not working, which members are working. So this is your overall analysis and design. So what we did, we finished our modeling. We did a general basic framing. We did some analysis. We did some loading on that framing. We have done the analysis using the first order or basic analysis. We have checked our analysis. We have done our design. So once all of these steps are done, what we do next is report generation. See, once we done finish our design, we have to submit our report in a live project. You have to submit your report. So report generation is also very important. The report generation can be done using that report ribbon, under the report ribbon. What another step before the report generation is you manage the settings of the report. There are a lot of information that you can omit or you can choose to show in a report generation. If you see the sample here I've given, it's a summary, it's a summarized information. It's not really showing you all the calculations. In case we want to submit all calculations, we can do that also. we can include the deflection diagram also. We can include your shear force bending moment diagram also under the report. So the report generation we can do for each member, we can do for framings, we can do for slab also. So once that is done, your report is done, your member design is done, so your model is ready. Next step in a project is what? You have to generate a drawing, because drawings are what goes to the next stage, goes to the site for construction. So Tekla also have an option of generating the drawings. How do you generate the drawings? What are the drawings that we need to generate? We need to do a plan first. So you see this plan? Here, if you see on top, there is an option for draw. So from that option of drawing, we can actually generate a plan looking exactly like this. That's called general arrangement. So when you extract this plan, in the general arrangement, you will be able to see the column sizes. You will be able to see your beam sizes. All that information will be captured in the general arrangement drawing. The next is the column schedule. Suppose if you have an RC column, how do we present an RC column in a drawing? We give a column schedule, like what's the column size, how much reinforcement do you need, what's the height of the column do you need. So all that also we can generate from the drawing option. Next is the beam detailing, RC beam detailing. Say there is a continuous beam. I need a bottom and top reinforcement drawing of that beam. So we can generate that also from the software. So basically you can generate all these drawings from the Tekla Structural Designer software. Once these drawings are generated, what we all just need to do is just clean this drawing a bit, and it's ready for your site. So once we finished our report and drawing generation, the next step is the beam integration. So as I explained earlier, suppose this model is done, I want to export it to some other software to cross check with architect. So I export it to Tekla Structures. There's an option here under beam integration. If you see here, beam integration after home. So we go there, we export our model to some other softwares like Revit or Tekla Structures. Then our designers will work on those structures. They will make the changes there. And once they are done with the changes, we can bring back those changes into our Tekla Structural Designer. And when we bring back here, we will be notified that, hey, these are the changes that happens. So do you want to do these changes or not? So we can choose, yes, we want to do the changes, and we update that change in our Tekla Structural Designer, and we repeat the process of analysis and design and go back to exporting. So this is the whole process of Tekla Structural Designer, okay? Starting from modeling to generation of drawing and beam integration if the project demands. So I guess after that, we are done with the Tekla structural modeling basics. I want to talk about the roles that we play as a structural engineer in industry at various levels, okay? Suppose when we are at an entry level, we do a lot of design, a lot of hand calculation apart from the software. So using the hand calculation, we will first learn, we need to first learn the bending moment and shear force diagram and the deflections of the framing of our structures, okay? So basically with the hand calculation and some software, we learn the analysis. Then we will, in the entry position, we will assist our senior engineers for a live project for design, and we will assist them for a preparation of design documentation and drawings. So from there, when we go to a senior level, at mid-senior level, the senior engineer will still be involved in design of buildings, but other than that, they will also be involved in additional jobs like handling the training of junior engineers, overall coordination of projects. It will be more of a client facing roles where they will be expected to attend technical meetings and provide solutions, and they will be responsible for the overall delivery of the projects, okay? So this is what a mid-level engineer job role looks like. So next, at manager level, The job description in the manager level is not so much of a design phase. They will be aware of what's ongoing in the project, what's the design going on in the project, but will not be limited to that. They will have a managerial role, like the description will include forming a team of engineers and designer to assist the project work. They will also manage the overall project works. Okay, they will also be involved in bidding and tendering of new project. Apart from that, the management level are also involved in the budget allocation of the team, and they will provide basically they are the support for the team system. They will overall working of the team. That's how the role works. So once we are done, I want to talk about Tekla structural designer application in one of a real time scenario. Okay, so here is a case study for an industrial building. Now, normally an industrial building will have a lot of equipment supporting structures. We'll have a lot of incoming and outgoing pipelines, pipings. So suppose it's a steel structure. When it's a steel structure, you will also have a lot of bracings for your lateral stability. So in this case, we were assigned to design an duct supporting system, and so we were supposed, for as a structural engineer, we were supposed to do the supporting arrangement of a ducting. But this one was for a constructed building. It means the building is already there, and then we have to go in and do the duct support system. So what happens in here is, the first thing, the layout and the loadings for the duct arrangements will be provided by the mechanical engineers. See, the challenge in this kind of project is, because it's a constructed project, constructed building, so there will always be some existing elements like bracings, like equipment. So when we were doing the structural arrangement, we already had some elements that were clashing with our proposed structural supporting structures. So what we did is, we would go to actually design the supporting system. We had to identify these locations, identify the points where it was clashing. Then we had to also identify the points where we were putting additional loads, and we would have to take design precautions. See, maybe because say some of the columns already have a utilization ratio of 0.8. It means 80% of it is already utilized. So when you're putting some extra load, you have to be very cautious about that, because you have to see how much that column can take that loading. Then the next one was, because it's already a building that's already constructed, it means it had a space problem. Suppose I need a beam of 600, but I don't have enough space for 600, because there is a tie beam there and I cannot fit my 600 beam into there. So these are some of the challenges that were there, and these are very common challenges that you will face when you're working on a constructed building. Okay, after identifying all this issue, we were supposed to develop a structural framings based on the mechanical inputs. So while doing this, we realized that it was not very easy to work on a 2D structure, because we cannot really visualize what's going on in the building. But for us, there was a good thing about this, because the parent model, the main industrial plan that we were working on, was actually developed on Tekla structures. So we already had that model. So what we did is, we imported that model from the Tekla structure. Then we use that model to identify all those places where we could arrange our supporting system. Any place where we couldn't, we used to go back to the mechanical engineer saying that, okay, you need to rearrange your duct, because you see this existing building have a bracing here. So this is the advantage of using this kind of software, this Tekla software. We could actually see all this happening even before we were in the design phase. So when all these clashes were cleared before construction, we could easily just go into the construction phase without any delay. And also, it eliminated the repetitive design process. Like, when I know where is my space to do a support system, I will design accordingly to that. It's not like I have to do it again and again. It's not like I position it somewhere and later we realize, okay, there's a bracing here. because we didn't see it in 3D environment. So that's what was good about this. So we exported this model from Tekla structures to Tekla structural designer. Then using the current model, we placed our structural supporting system. We modeled using angle bracings, and we modeled small platforms to support all these ducting arrangements. So once it was done, there were no clashes in the building and the construction was really smooth. So this was one very useful application of Tekla Structural Designer that we had in the design of this ducting arrangement. Once this was done, we also generated the drawings directly from the software. So we didn't really have to go and do 2D drawings in AutoCAD. That's time taking. So you see, this one was with a successful use of Tekla Structural Designer. Now let's talk about the requirements you need to get into this domain. I mean, if you really want to work on this kind of projects, so what are the requirements you need? First and basic, you need an educational background in civil engineering. If you have a master's in structural engineering, it's good also. It's really good. You will have all this understanding of analysis and design of structure. Next is you need a very clear understanding of how loading works, of how loading flow. You need to have a very good understanding of bending moment diagrams of frames, of single beams, lateral load, using combinations of loads. That's the basic and first requirement. After you're clear about analysis, you can go to your design. So for design, you need to have a good understanding of codal provisions. You need to go through the codes and the provisions that's there in the codal codes. I'm not saying that you have to remember every clause, no, but you should have an idea that if you are doing a beam design, what are the points that you have to consider for a beam design, okay? Because even when you are running into a software, we always have to be very alert about how the software is actually running your beam design, how the software is designing, what are the steps it's doing. You have, because you have to cross check, it's very important. So that's why we need to have a very clear understanding of all the provisions that we have inside the code. So once you're clear about these code clauses, the next is problem solving skills. You will see there, you will always encounter one or other problem while doing analysis. You will always have some space problem, you'll always have some restrictions. So you have to be very creative, very innovative in your way of thinking about how to solve a problem, and have to be very calm and composed about that. We have to generate a lot of drawings. See, no matter how complex your design, your model is, the output have to be very simple. It have to be simple so that the people inside can actually read your drawing easily and can understand that, because they have to carry out the works on an open field. They don't have grids on their field. So our drawings, our representation of all those information have to be very simple. That is also important. You need to develop this ability to represent all this complex information in a much simpler way in our drawing. One of the main thing is this creativity. You have to be creative enough to think about how you're going to arrange a structure, and how can it be effective, how can it be economical as well, because that's also very important. And it has to function, if the functionality of the building has to maintain. If you are working on, say, a mall, it's very important to take care of architectural needs, because when people go inside a mall, they look at the beauty of it. So we have to design the building considering the functional requirement of the building. Apart from its safety, safety is important. Functional requirements also important, and to design a cost-effective structure is equally important. So these are some very basic idea of how you can improve yourself, or how you can work on yourself to get into this domain.